Okay, so what we're going to look at here is some square baler nodder, how it functions, and also what happens when it's not working properly, figuring out how to identify the causes of various different misties. This right here is a picture of a typical square baler nodder. This one here would be on a small square. There's only 2 nodders. So if we take a look at the baler overall, there are a bunch of different parts identified here. Number 1 being your pickup. And the pickup is going to move hay into number 2 area, and you're going to have your stuffer arm. Your stuffer arm is going to put hay into the hay chamber, which is number 3. And then we're going to have a large pitman arm that moves a plunger back and forth. Number 3 looks like that's actually the plunger that's moving back and forth in the bale chamber there. If we take a look along, we can see number 4 is showing us our nodder mechanism. Number 5 is showing us our bale length metering mechanism. Number 6 is going to be the trip. Number 7 is going to be our needles for the twine. Number 8 is going to be our bale tension, and that's how we squeeze the rear of the bale chamber down to increase the tension so we can make a more dense or a less dense bale. And then I'm not quite sure what number 9 is pointing at, probably the bottom of the bale chamber. And number 10 is just the back of the baler where we drop the bale off. So getting back into the nodder here, several different components. We'll take a closer look at those when we get into the functional pictures of it. But the 2 nodders that we see here, they do work in unison, and they only work once they've been tripped because we've got a long enough bale. This right here is just showing us how the twine needles sit in the rest position, and the twine needles need to be in the rest position as we're building the bale. The only time the twine needles move up into the bale chamber is when we're trying to tie and complete the bale and start a new one. Here we have a look at a plunger. One thing to know about the plunger is we do have a knife on the plunger, and you can see that right on the edge of the left-hand side, or sorry, the right-hand side of that plunger that's shown upside down. So that knife right there, the whole purpose of that is so we can cut off the hay so we get a nice clean slice to pack into the bale chamber. Over here you can see the other side of where that knife rides. Here we're calling it the stationary knife. The stationary knife and the knife on the plunger, as they come past each other, they shear off that hay. The hay dog, as you can see, is a spring-loaded tooth that pops up into the bale chamber there, and that retains the hay that's already in the formed part of the bale so that it doesn't pop back out into the bale chamber. That lets us make a nice even bale. One thing to be aware of is if your knife on your plunger or the stationary knife is excessively dull, that can rob a lot of power from the baler, and it can cause increased horsepower requirements. So making sure that your plunger is moving smoothly back and forth in the chamber and the knife is sharp right there is pretty important so that we don't rob horsepower. Here we're getting back into the nodder and the needles. Okay. Now we're starting to get a close-up look of the nodder, and here we're going to draw a little bit on here so we can see a bit clearer what's going on. So this is looking straight down at the nodder, and this right here is the needle, and you can see the needle has got a twine coming up right here. All right, now that twine, that is being carried up against the front face of a finished bale. You can see kind of ragged over here, that is the back of the twine that was wrapped all the way around the bale. So if you can just imagine your bale sitting like so, okay, and there it is. And your twine, let's go ahead and use blue for that twine. So your twine is going to come around the bale, okay, and it's being carried up by the needle, and then it goes back down to your twine box with the remainder of your twine. And that gives us basically 3 twines. If you're talking about twine and mistie diagnosis, there's different things that it's called, but I'm just going to call them number 1, 2, and 3 twine. So your number 1 twine is the one that's held. Your number 2 twine is this side of the twine that got carried up by the needle, okay? And this one here, we could call this number 3, but the reality is that's actually your new number 1 twine once this bale is finished, because that one gets held in the knotter and the bale forms, and as the bale forms, it just continuously pushes back and pulls twine out of the twine box and up around the bale. So what's going on in the picture here? Our twine is being carried by the needle up across this guy right here, and this you can see is this disc with these kind of notches in it. That's called the twine disc. The job of the twine disc is to hold the twine while we're making the bale. The twine disc is rotated by this gear right here, and that twine disc, it only rotates about I'm not going to say exactly how far it rotates, but it rotates every time we're making a knot. That's the fairest way to say it. Okay, so every time we're trying to make a knot, your twine disc is going to rotate. And not only does a twine disc rotate, something called the bill hook rotates as well. The bill hook is the thing that we use to actually tie the knot. It's kind of like when you're tying a knot around your finger, so you just loop the rope or whatever it is around your finger and pull it through. That's what happens inside this mechanism. Okay. So a few things that we have to do. We got to make sure that when the twine needle comes up, we have to have the twine disc, that's this right here, we have to have the twine disc timed correctly so that the needle lays the twine, the number 2 twine, across the twine disc. It's very important that that happens. As that needle lays the twine across the twine disc, it ends up resting in one of the grooves. And then as the twine disc turns, it gets pinched between the various plates of the twine disc to keep it securely lodged in there. Now, if we take a look over here, this picture is a little bit, once you know what's going on here, then it's a little clearer, a little easier to see. The knotter is actually not on this picture, so you can see what's going on, because we're trying to look at this piece right here. And as you can see, that kind of looks like so, okay? And that right there is your tucker arm. So the job of a tucker arm is to make sure that your number 2 twine, which is this guy right here again, your number 2 twine is held against your twine disc, and your twine disc is that thing that's going to be sitting right here on your knotter mechanism. So when this twine comes up, we want it to rest in the notch of the twine disc. And to make sure it stays where it's supposed to stay, the tucker finger here, it actually pivots around like so, and now it holds the twine tight against the twine disc. All right, so right now what we're starting to see is a couple of things that can be problem areas. First of all, we got to make sure that we're laying in one of those notches in the twine disc. Twine disc timing, very important. Secondly, we got to make sure that the tucker finger is pivoting over and grabbing the twine. If there's anything wrong with the timing or the adjustment of the tucker finger, then it's not going to hold the twine tightly against the notch in the twine disc, and we may end up missing the bill hook, and then we end up with a mistie. Okay, so if we end up with a mistie and the bill hook swings around and it ties a knot, it's only going to tie a knot in the number 1 twine, right? Because this is our bale, remember, this is our twine. So we're going to end up with a knot here. But if the tucker finger didn't hold the number 2 twine up against the bill hook when it was trying to tie the knot, we're going to miss that number 2 twine, and we're only going to get a knot in the number 1 twine. So your tucker finger is very important that they're adjusted so that they don't miss the twine when they swing around. And from this picture, I think it's clear enough to see that what we're trying to do is catch the twine right here with the tucker finger and just pull it around so that it rests nice and tight against the twine disc. if we take a look at this picture here, I am just trying to see if we have a clear, this will work. Okay, so coming into this picture here, you can see that we have the needle in the upward position. We have our number 2 twine fed through the needle, and you can see, remember those grooves I was talking about? Now that groove, it used to be sitting right here, but it's not because we've started to turn the twine disc and the bill hook. And as we turn it, it takes the number 2 twine and it pulls it around and it pinches it between the plates of the twine disc. If you take a look underneath this right here, and I'm just going to kind of draw this virtually for you, that was your tucker finger. And what it's doing is it's actually holding that twine up against the bill hook, and the bill hook is on the bottom of this shaft. Okay, so what we're trying to do is we're trying to hold that twine securely, and obviously in this case we did it because the twine got carried around. If the tucker finger hadn't been adjusted properly or the twine disc timing hadn't been set properly, we wouldn't see the number 2 twine being carried around the twine disc. It would actually be sitting in here and it would have missed the knot. Now, this is a look at the underside of the knotter. And the underside of the knotter has got a couple, there's a few different things happening here. This, and it's a little difficult to see, but this right here, that's your bill hook. And your bill hook, you can see you've got your number 1 and your number 2 twines that are laying across the bill hook. And as it turns around and completes a circle, it ends up wrapping this twine around itself. And you've got this little hook right here. That's why it's called a bill hook. That ends up grabbing the twine so that we can make the knot. Okay, and once we make the knot, the bottom of the knot, or well, the knot itself is wrapped around this bill hook. And then we have this guy right here, this big thing, it's called a wiper arm. That wiper arm does 2 things. What it does is it kind of scrapes the knot off the bill hook, but there's also a blade on it right here. And you can see that blade right there. The job of that blade is to cut off those twines. So we cut off those twines. And the twine that we have, the number 1 and number 2, those 2 twines are now the knot for the bale. And then the other twine, which was coming up the back of the needle, that twine now becomes your new number 1 twine because that one's also trapped in the twine disc now. Okay. And let's see if we have anything else. This one here, this is a pretty good shot of what happens when we wipe the knot off of the knotter. Okay, so the knotter and the bill hook and everything here, we've got that knot held secure. You can see the knot right here, and there's the ends of the knot. The ends of the knot, okay, and the knife right here, that's made a nice clean cut. If you end up with an issue where we're not cutting the knot off of the new number 1 twine because our knife is dull, then you can end up with the twine pulling out of the twine disc. If your twine disc tension is not tight enough, you can end up with your number 1 twine pulling out of your twine disc. And then you end up with only a knot in your number 2 twine, not your number 1 twine. Okay? So remember, your twine disc is holding your number 1 that goes around the bale, and your number 2, while the bale is forming, your number 2 twine is just sitting here, and then there's your needles, right? There's your needles. And then as your needles move up, that carries your number 2 twine up, and your number 3 twine, which is going to become your new number 2 twine, or sorry, your new number 1 twine, it's got to get trapped in the twine disc as well. So common knotter failures. I think that's another thing we should talk about here. If you end up with, just let me get out of this. Okay, so that's the end of this one. So if you end up with a problem where you have a number, here we go, a number 1 mistie. a number 2 mistie. Okay. A frayed cut. Okay. So banana bales. And try that again. Yeah. There we go. Banana bales. You know, so some common things that can happen, or bales that are too loose or too tight. Now let's start with our number 1 mistie and talk about why that could happen. So number 1 mistie, prime reason for that happening is that the number 1 twine fell out of the twine disc. Okay. And that's usually because the twine disc tension is not tight enough. Yeah. A number 2 mistie, the typical reason why that would happen is because one of 2 possibilities. All right, and the only way to know is to cycle the baler until the needle is moved all the way up into the tying position and look at where the twine is laying. If the twine is laying as it should in one of the grooves of the twine disc, then twine disc timing is not your problem. Okay, but if it happens to be laying somewhere off of one of those notches in the twine disc, then twine disc timing is your problem. If you got a number 2 mistie, the other possibility is that your tucker finger didn't actually grab the number 2 twine and hold it up against the twine disc and up against the knotter while we were trying to make the knot. All right. So that would be your tucker finger. Tucker finger adjustment, I think, is probably the best way. Okay, so your tucker finger adjustment, very important you have that set properly. And when your tucker fingers are adjusted properly, both twines should be laying, well, not both twines, but the number 2 twine should be laying across the notch in the twine disc, and we should also see it laying alongside number 1 twine on the knotter. If you end up with a frayed cut, the most likely reason for a frayed cut is your knife on the knotter, the knife that cuts the twines on the knot, is dull. If you end up with banana-shaped bales, there's a couple of different possibilities here, but one of the more likely ones is that the bale tension is not evenly adjusted from side to side. Some of them have a single point of adjustment, some of them have 2 points of adjustment where you have 2 adjustment knobs on the back to squish the bale chamber together. So if your bale tension adjustment is not even, that can give you banana-shaped bales. Another thing that may or may not be an issue is if your twine tension is not even, that can also cause banana-shaped bales. The twine, as it comes out of the twine box from your rolls of twine there, it goes through a tensioner. And the tensioner is usually just 2 simple little plates that are squished together with a couple of spring-loaded bolts, and that gives you the proper tension on your twines. And if there's not enough tension on, say, one of the twines and proper tension on the other, then you've got a loose twine on one side, and that'll cause a banana-shaped bale as well. Okay. Excessive horsepower consumption. That plunger, as it moves back and forth in the bale chamber, it moves back and forth on rollers. So if the rollers or the guides are excessively worn, what that's going to do is it's going to make it harder to move the plunger back and forth. And that's the heaviest thing that's banging back and forth inside of there. And it takes a fair bit of horsepower to make that happen. So if you got seized plunger rollers, you're going to end up with excessive horsepower consumption and also a dull plunger knife. Okay. So dull plunger knife, what we need to do is we got to have that plunger knife sharp enough so it can cleanly slice off that charge of hay that's in the bale chamber, so we can pack that into the bale as the plunger moves back. Okay, you think about something like a forage harvester. If you got dull knives on a forage harvester, you know that's going to take a lot of extra horsepower for that thing to run that it doesn't necessarily need to. Same thing applies here. What else could we talk about here? So excessive horsepower. Now, some balers use an auger to charge the bale chambers. Some of them use, some stuffer arms. But if you're using an auger and you've got hay wrapping around your auger, and this applies on balers, it also applies on augers, on your, say, a pickup for a combine. So anytime that you've got an auger and you've got straw or hay or something like that, you want to make sure that the auger flighting is nice and smooth. If the auger flighting isn't nice and smooth, then what will happen is you're going to get the stalks of whatever crop it is that you're running through it starting to catch and wrap, and you can end up with a big tangled up mess in your auger. So if your auger's got jagged edges, and there's another thing that you may or may not find, it depends on the particular design, but that might be, okay, a stripper. Okay, so stripper plate or stripper bar, whatever you want to call it, but that stripper is there, and it basically just wipes the material off the auger. And if you're familiar with combine pickups, I'm sure you've seen this, and we got to make sure that we have the right gap there so that it does what it's supposed to do. So if that's something you have on the baler, great. If it's not, then just make sure that the auger itself has got nice, smooth flightings on it, because if the flightings aren't nice and smooth, it's going to be grabbing that hay, it's going to wrap it up, it's going to make an absolute mess inside there. So there we have some basic information on how a square baler functions, some good information on the types of problems, typical problems that we're going to come across with square balers, and what to look for to troubleshoot them.